All right, this is a really short video lesson where we are going to introduce some reactions of hydrocarbons. We're going to be using these reaction types throughout the rest of the unit. So this lesson is just introducing you to the types of reactions that hydrocarbons will undergo. So the first thing that we should mention is that you're going to want to have a copy of this handout from your teacher. If you do not have a handout, you're going to have to write the whole thing out. So the first reaction of hydrocarbons, that really popular reaction that everybody knows, is that hydrocarbons burn in air to give carbon dioxide and water, and they release a lot of energy. So that is basically the chemistry behind using fossil fuels for energy and for heat. Another thing that I really want you to really be familiar with is that hydrocarbons have different reactivities. So when we're looking at reactivity right here, alkynes are the most reactive, followed by alkenes, then aromatic compounds, and then finally the alkanes are the least reactive. This is because of the multiple bonds. Double and triple bonds are actually significantly less stable than a single bond, which is kind of the opposite of what people would expect. A double bond and a triple bond, just because of the nature of how the bond forms, they're not as strong as a single bond. Okay, so when we are thinking about combustion, the very first thing right here, I have an example of a combustion reaction. The next type of reaction I want to talk about, they're called substitution reactions. So a substitution reaction, we'll do blue. Substitution reaction involves alkanes. Because the alkane is very unreactive, a more prevalent reaction is when a hydrogen atom is substituted by a halogen atom. And when we do that, we get something called an alkyl halide. We may or may not have learned how to name alkyl halides, but if we have not, we'll do it soon. So in this example, what happens is if we have an ethane and bromine gas, this bromine ends up coming over here. It substitutes out a hydrogen in the compound. That's it. A halogen substitutes out a bromine. So that's the first one. Now, then this bromoethane that we see right here, this bromoethane can undergo another substitution reaction, which we'll see over here. And now this hydrogen is getting replaced by this bromine, and now we have 1,2-dibromoethane right here. Okay, so that's our first substitution. That's a substitution reaction. Another type of reaction that we're going to look at, they are called addition reactions. So an addition reaction involves an alkene or an alkyne. So they're very, very reactive. So a reaction for an alkene and an alkyne requires less energy than a substitution reaction of an alkane. Basically, in an addition reaction, there is no loss of hydrogen. What happens is a bond gets broken apart. The bond that gets broken apart is this double bond right here. The first type of addition reaction is a halogenation. So the double bond gets broken, it breaks apart, and each carbon atom involved ends up bonding to a bromine. So we break apart this double bond that I highlighted in green, and each carbon bonds a bromine. So the electrons involved in this double bond that we've broken, they're now used to connect a bromine. And these electrons in this bond are being used over here to connect the second bromine to the other carbon atom. The second type of addition reaction we're going to look at is hydrogenation. So hydrogenation is exactly the same type of reaction as a halogenation. We take a double bond and we break it apart. So this double bond here, it gets broken apart. Those electrons are getting used to connect a hydrogen instead of the halogen. So the electrons involved in that double bond create the bond to connect the hydrogen, and the electrons involved in this bond are going to be used to connect this hydrogen to the carbon. So again, we've just had a different type of addition reaction, but instead of adding a halogen to the hydrocarbon, the hydrogens are getting added to the hydrocarbon. So these two hydrogens move over there. The third type is called a hydration reaction. So hydration reaction sounds exactly like it is. We have a double bond, it gets broken apart, and instead of adding a halogen or hydrogen, we're breaking apart a water molecule and adding a hydrogen and a hydroxide. Pink, maybe green. So these electrons in this double bond are going to be used to connect this hydrogen, and I don't know. Those two electrons here are going to be used to connect the hydroxide. So in hydration, this hydrogen is going to come here. This hydroxide is going to come here. And it's important to recognize that the hydration reaction requires a catalyst. Okay, so just remember that we need a catalyst for hydration. That's going to become important a little bit later. So when we're dealing with an addition reaction, all we're doing is breaking apart a double or triple bond and adding atoms to the carbon atoms that were double bonded together. So the fourth type of addition reactions is on the back of your page, and on my page, it's upside down. It's called hydrohalogenation, and it's exactly the same thing. We have a double bond that we're going to break apart here, and what we are adding to our molecule is a hydrogen and a halide. So the double bond breaks apart, and we are adding to our molecule. The hydrogen's going to bond here, and the bromine comes and connects over here. So exactly the same as the other types of addition reactions. On the other side of the back of this, which my page is upside down, it gives you a little summary. So alkanes primarily undergo substitution reactions. So these are important. Alkanes undergo substitution reactions. They need heat or UV light. Alkenes and alkynes, they undergo addition reactions, and the addition reactions are hydrogenation, halogenation, hydration, or halohydrogenation. So just remembering the big key things here: alkanes undergo substitution, alkenes, alkynes undergo addition reaction. On the bottom of your page is a couple practice that you'll be able to read because your page is right side up, that you should give a try today. And we will continue to talk about these types of reactions throughout the next few days in class, because we're going to start using them to create different types of organic compounds.